A stunning visualization of Greenland without its ice cover has been revealed, and it could help experts understand how this huge expanse might respond to climate change. Made from decades of survey data, researchers have found, if all the ice on Greenland melted, it would raise sea levels by 24 feet, 7.4 meters. The visualization shows the shape of the bedrock and surrounding seafloor, revealing how glaciers draining from the Greenland ice sheet will contribute to future sea level rise. Produced by researchers at British Antarctic Survey, BAS, University of Bristol and University of California at Irvine, UC, the printed map is unveiled this week at the American Geophysical Union meeting in New Orleans. Greenland Basal Topography BedMachine V3 is the new 13,500,000 scale map created from data collected by over 30 institutions, said BAS cartographer Dr Peter Fretwell, who was involved in producing the map. This new compilation of the 3D landscape beneath the Greenland ice sheet provides the first seamless transition between the landmass and its adjoining seabed, and this gives scientists a bird's-eye view of the fringes of Greenland, which are experiencing the most changes, he said. The visualization, created with the help of radar that is able to penetrate through clouds and ice, shows the highest peaks in red and the lowest lying land colored in green. Looking at the hidden landscape, researchers are now confident ice streams on top of the valley systems were cut by rivers that flowed across Greenland before there was an ice sheet. What's also surprising is that there is more ice, and the bed is deeper in some places than previous maps suggest, so this means the total contribution from the ice sheet to global sea level rise would be 7.42 meters 24 feet if it were to melt completely, slightly higher than previously calculated, said Dr Fretwell. The data required to compile the map was collected from many sources, from satellite, airborne and ground-based radar and seabed mapping from research ships. It reveals that many glaciers that drain the Greenland ice sheet are thicker than previously estimated and up to 330 feet, 100 meters, in places. It also shows they have complex geometries that will control how they react to changes from the effects of warmer ocean currents, said glaciologist Dr Jonathan Bamber at University of Bristol, who had a project to develop the printed map and data set. This map will improve our understanding of the ice-ocean interactions and how the ice sheet will evolve in a changing climate. Andreas Ahlstrøm and colleagues from the Geological Survey of Denmark and Greenland used measurements of meltwater runoff and glacial lake outbursts, where a body of water contained by a glacier overflows. They collected this data at a catchment during a 40-year period of the ice sheet's life. The catchment measured discharge from over 4,000 square miles, 6,500 square kilometers, of the ice sheet, including several ice caps that feed into Lake Tursisiak in southwest Greenland. The authors found an abrupt 80% increase in runoff occurring between 1976 to 2002 and 2003 to 2014. With further analysis, they correlated this increase in water loss to changes in atmosphere circulation, such as increased north-south and south-north wind flows, frequent periods of stagnant weather, and a wavy jet stream. These are all patterns connected to global warming. Some of the deep fjords have tall ridges that stop warm bottom water coming in. What we're starting to understand is that adjacent marine terminating glaciers that are experiencing the same changes in forcing, in other words, the same changes in the ocean, can respond in very different ways depending on the geometry of the fjord in which they lie, Dr. Bamber told BBC News. So, the better we can constrain these geometries, the better we will be able to model the interaction between the ice sheet and the ocean. At AGU, there are lots of sessions on this interaction. It's kind of the big thing at the moment.